Hello guys and welcome back. So this is what we've got with the global illumination turned on, and let's set this back to 1, and with motion blur turned on as well. So what I'm going to do is I'm going to tint the environment light a bit more. I feel like the sun is taking over. I'd like to get some blue here, so I'm going to do two things. I'm going to lower the environment, the sun a bit, and desaturate it a tiny bit so it doesn't take over everything. And then here I'm going to tint the environment light with more blue, and I think that should improve things. And let's do a quick render again with GI turned on. I'm going to increase the global illumination bounces to 2, and let's see if that improves the black areas here. Now in terms of particle rendering for this scenario, we're going to use PBR. You guys can use any of the other methods that we talked about in week 4. They're all applicable. In this week, I'm going to use the PBR, which is the physically accurate way of rendering particles. And we're also going to get some cool, interesting visual using this engine. So here, I'm not so sure why the normals are. Could be because of the LUT. Yeah, I'll check this later. Just these guys. Maybe the normals needs to be fixed. But other than that, I think it's working pretty well now. Well, I think we can go a bit more saturated on the blue. And let's increase the environment light even more and lower this to 1.5. I want to get some nice shadows here. And I'm also going to rotate the environment light. I feel like it's hitting a lot the geometry, so I want to cast the shadows a bit more here. I think that should do it. Okay, so I'm not going to do a render. I'm going to start looking at the particles, and let's turn this on. And for the particles, we're going to create a material builder, and we're going to build a shader from scratch. Not from scratch, I want to control a few things. So let's call this particles. Let's dive inside and create a principal shader core. And this is basically the same. It just has less features in the UI. So let's connect this. And let's make sure everything's working. So let's set the color to red. And let's assign this to the particles. And I want to create a new separate path, so let's call this particle beauty. And in this path, I'm going to use the environment as matte. So everything except the particle is going to be set as a forced matte. The ground and the distraction geo. And then in the forced object, I just want the particles. And this way, we're going to get the particles like I showed in the previous play previews. Okay, let's do a render. Let me check how much points we have. 10 million points. I added that transform so that it matches the scene scale. Cool, everything looks good. Let's go back to the material and let's turn off the reflection. And in the color, actually let me do this in SOP so you guys can see it better. I'm going to create a point VOP. These points, they have an ID attribute on them, and that is constant, that sticks to the geometry, and I'm going to use that to randomize, to generate a random color that I can specify. So I'm going to use a random function based on the ID, and let's connect this. Cool. So it's giving us a value that goes between 0 and 1. We know this for sure. And I'm going to connect that directly into a color ramp. And I'm going to remap this random function to colors. So basically, if a point has a value of 0, it's going to pick up this color. If a point has a value of 1, it's going to pick up this color. And then in between, anything in between basically. So I'm going to set this to constant. I'll explain why in a second. As you can see, when I move this, it's basically 50% is white and 50% is black. And I like this constant mode because we can control how much particles we're getting, how much colors we get from each particle. And I'm going to set this to have something like this. And I'm going to randomize the color in various places. This. So this is my base layer, and then I'm going to start clicking in here. Let's turn off the interactive playback, the auto update. I'm going to start clicking and put 2 dots to trim the colors, or basically stop the color from changing. And then inside here, I'm going to give this a very different color, and this is going to create a much more interesting visual. Let's see, something like this. I want to have something that pops and is clearly different than the rest. So something like that. We only have this tiny section that has that color. And then here, for example, I'm going to set it to a much darker color. In here, I'm going to give it a brighter color. And this is just a nice way of breaking up the colors without and being able to control them precisely. So basically, we're getting a good percentage of this, of this, of this, and this, and then breakups in between. So I'm going to pass this to the shader, but in theory, it's much better to pass in a float attribute or an integer attribute instead of a color, because that's going to save us time. And then in the render, in the shader, we can do the same process here. So let me show this again. Under the material, we could have done the same thing here, but I wanted to show the preview in the viewport. So we can import the ID, same thing we did in SOPs, and we can generate the same random function and use a ramp the same way we did it in SOPs. Okay, but instead I'm going to import the color attribute, the CD attribute, and connect that directly. Okay, let's hit render, see what we get. So make sure, yeah, we have 2 GI. We don't need that. Definitely, we're not going to be able to afford rendering particles with GI only for the environment. I mean, you can, but it's going to be quite slow. Cool. So you can see the variations here. Okay, let's do one more thing. Actually, I like this a lot. So we could do a portion of the particles that have a higher P scale, and then the rest will be much finer. Actually, let's do that. So let's go back in. So let's separate these guys. and say generate a random function based on the ID. So this is going to give us a random number that goes from 0 to 1. And let's say if the point, so if the random ID is less than 0.15, I want the p-scale to be 1. I don't want to change. I like this value that I'm seeing here. So only 15% of the particles will have a p-scale of 1. And then here we can just do, before this we can say f, or actually let's do it in a much simpler way. Let's create a randomized node and let's type in a p-scale for the name, and I'm gonna say it's a one float, and I want to randomize it between 0.3 and 0.7, 0.25 and 0.7, and then this will only get executed for 15% of the particles, okay, where the particle will be much bigger, will be overwritten. So let's take a look at these guys. So here you can see the p-scale is between 0.25 and 0.75, okay, and then if we take a look here, we're gonna have a portion of them that have a higher radius, which is 1. You can see it there, and this is going to help break this up even more. Let me double check the velocity. Okay, we have a velocity vector, and I'm gonna turn on geometry velocity blur, and let's go back to the render. And for this pass we definitely need a lot of samples, and this is why I want to render this separately, so that we don't have to render the environment and everything else with the same settings. So here we have inv beauty, and we can turn on GI, set the shading, set the samples to 3x3 or 5x5, and then for the particles we can increase that without having to worry about this affecting the render time of the environment. And this also gives us more control in compositing. So I'm going to set this to 10x10, and that's it. Let's hit render. I forgot to turn on motion blur. That's fine. I think the render that I did had much smaller points. If I can, yeah, this one. Yeah, definitely, it has a much finer points. And this is totally up to you guys. I mean, there's no rules to follow. As long as you're happy with the visual, you can set the values to whatever you like. So it's taking a bit longer because there is more attributes that needs to be passed in, and you can see the point size is quite big, but you can see the randomization that we're talking about. And before, the p-scale was not defined. I think Mantra was using 1 across the board, and now that we have this, it's using it, it's giving us bigger points. So we just have to multiply all this using the point scale. So we can use the geometry tab here and set this to 0.03, similar to what I had before, and that will apply a multiplier to scale down all the points. You can see the color randomization, which is very cool. And now we have motion blur turned on as well. And in these two renders, I did them separately. I did the volume separate from the... Actually, let's load the LUT because it's very important for the visual. And same here. I did the dust or the particle separate from the smoke, and they can definitely be rendered together. Actually, you can get some more interesting visual and break up this volume, uniform volume, using these points, and that's something that you guys can explore doing, and I will do a test render and show you guys. We have to do various tweaks for the volume so that we can see through the particles, and also we have to change the particle size so they don't disappear inside the volume. And I love this render. It's actually looking much more interesting than this one. I think the sun could be a bit stronger. Yeah, definitely we can increase the sun a bit more. But overall, I'm pretty happy with this look now. Yeah, I'm going to increase the sun to 2.25. And I want to cast shadows onto the particles as much as possible to get these nice different shades, like here, which looks very, very interesting. Cool, so I'm going to do one more thing. Let's go back up. I'm going to increase the settings a bit more, 12 by 12, change the resolution to 1920 by 1080 so we can see all the details of the particles, and we're going to start looking at volume rendering in the next videos. Thank you guys for watching, and see you in a bit.